Well, good morning everybody and welcome to our Enrich webinar. I'm Alison.
And I'm Liz.
And yeah, it's really good to see how many people have joined in the chat so far this morning. If you haven't already introduced yourself and said whereabouts you're joining us from, it would be really good to see that. But I think we're going to start by having a look at what we did for the warm-up task.
Yeah.
So you might like to compare it with what you did for the warm-up task. So Liz, how did you approach it?
Right, well I didn't have any blocks to hand, Alison, so I took some coloured pens. First of all, I imagined I was going to put the blocks together sort of any old how. So I put a red on top, yellow, blue. And then to make a new arrangement, I decided to sort of do a rotation, if you like. So I took the red to the bottom of the tower, so it ended up on the bottom, and pushed the other ones up. So now I've got a new arrangement, yellow, blue, red. And then I did the same again, took the yellow to the bottom to make a third new arrangement. And then I realised actually if I did that again, I'd end up with exactly the same arrangement as I got here, so it wasn't new. So going back to that first one, I thought, okay, I wonder what would happen if I'll keep the blue on the bottom, but I'll swap around the red and the yellow. So that gave me a new arrangement here. And then I did that same rotation again. So I put the yellow at the bottom and moved the others up to give me a fifth solution. And then I did the same again, took the red to the bottom, and that gave me 6 solutions. And I thought, okay, what else can I do now? And then I noticed actually that I've got 2 solutions with blue at the bottom. I've got 2 with red at the bottom, and I've got 2 with yellow at the bottom. Now there's no other cube I can put at the bottom, and there isn't another way of having a blue at the bottom. So I was satisfied I've got all 6 solutions. Did you do something different?
Yeah, a little bit. It's,
okay.
It's similar. So I didn't even have any colours, Liz. I didn't have any cubes, didn't have any colours.
Doesn't matter.
So I came up with a shorthand. I decided that R could be red, Y could be yellow, and B could be blue. And I started by saying I'm going to put the red on the bottom and see what I can do. So I put red on the bottom, and then I could either have yellow, blue, or blue, yellow on top of that. And that was all the ways I could do it with red on the bottom. And then I said, well, what if blue was on the bottom? So I put blue on the bottom. I could have red, yellow, or blue, yellow, red. And that was the only ways that I could do it. And then I tried yellow on the bottom. I could have yellow, red, blue, or yellow, blue, red. And that was every possible colour that I could have on the bottom, so I knew that was all the ways. So I found the same 6 ways that you did, but in a slightly different way.
Brilliant, great. So I wonder how you did it. I think the interesting point is that both Alison and I have used a system. We've got a way of working, an order, so that we are absolutely certain that we haven't missed out any solutions. And this, we call it, a mathematician would call that working systematically. And that's going to be key to our main challenge today. Alison, are you ready for our main challenge?
Yeah, I think I might be.
Good.
Are you going to show us it on the visualizer?
I will.
Okay. There we are.
Okay, so I've got some digit cards here, and I'm going to arrange them in 2 cross shapes. There's one cross shape.
Okay.
And then I'm going to do another one over here. And just make sure it's separate so you can see. Okay. So, Alison, just let's have a little think about what we've got here, and you, back in your classrooms, I'd like you to consider this too. What do you notice about these 2 cross shapes, Alison? For example, is there anything the same about the 2? Is there anything that strikes you as being different?
Okay, I'm going to have a little think.
Yeah, do.
Well, the first thing that I've noticed is that both of the crosses are the same shape as each other.
Yeah, that's really important.
They both use the numbers from 1 to 5. So I've got 1, 2, 3, 4, 5 in that one. I've got 1, 2, 3, 4, and 5 in that one.
Great, and that's also a key thing. So we're going to be using the numbers 1, 2, 3, 4, 5.
Okay. They're different because that one's got the 1 in the middle and that one's got the 5 in the middle.
Yeah.
So that's the way that they're different. They've both got the 2 at the bottom though.
They have indeed. What about, I wonder, have you looked at all at the totals in a vertical direction and the totals in a horizontal direction? Let me give you a little minute to think about that.
So for the one on the left, my horizontal total, 4 plus 5 plus 3 is 12, and my vertical total, 1 plus 5 plus 2, that's 8.
Yep.
Okay, so they're both even numbers, that's quite
They are,
interesting.
yeah, well spotted, yeah.
4 plus 1 plus 3 is 8, and 5 plus 1 plus 2 is also 8.
Right,
So
okay.
that's quite interesting.
It is, isn't it? It's, so it's this particular cross on the right-hand side here that I'd like to focus on.
Okay.
So the fact that you've noticed that the horizontal total is exactly the same as the vertical total is key. We're going to call a cross that has the horizontal total equal to the vertical total a magic cross. So this brings us to our main challenge. I would like you at home, back in your classrooms, to have a think. Can you find any other magic crosses? Remember, we're only using the numbers 1, 2, 3, 4 and 5. Maybe you can find more than one. Perhaps you could find all of the magic crosses using the numbers 1, 2, 3, 4 and 5. But how will you know that you've found them all?
Now, while you're working on this, a couple of things to be aware of. First of all, the chat is a brilliant place if you've got a quick question to ask about the task, for us to help you to understand it, or if there's any problems that we might be able to help you out with. If you think you've got solutions to the task, please don't point those into the chat because that might spoil it for someone else who's still working on it. But what we would like you to do with your solutions is to take a photo of it, and then underneath the chat window there is a link where you can upload any photos together with your name and the name of your school, whereabouts in the world you are, so that we know where things have come from. And in about probably 7 or 8 minutes time, we're going to come back and we're going to have a look at some of those solutions. What you'll see on the screen then for the next 7 minutes is a slide reminding you of the problem so that you can continue to work on it, and we're going to start a 5-minute countdown timer like the one that we had at the start so that you'll know when to get ready for us to speak again. So, good luck.
Good luck. Welcome back. It's very clear from the chat that you're thinking about this just like mathematicians do. We're delighted. We thought we'd come together for a short time to share some of the thoughts that are on the chat and talk about those a little bit, and then we'll give you a bit more time to work on the task. Xavier has asked a really important question. He said, does switching the numbers around count as making a new cross? Alison, what do we think about that?
Well, should we just have a look on the visualiser?
Great
at the
idea.
cross that we started off with?
Yeah, so this was the magic one.
This one. I think what Xavier means is that because we've got 4 plus 1 plus 3 here,
That's right.
if I swap the 3 and the 4 round, I've got 3 plus 1 plus 4 now. I know that 4 plus 1 plus 3 will give me the same total as 3 plus 1 plus 4.
Yeah.
So we have to decide
Yep.
whether this counts as 2 different crosses,
Yep.
or whether those 2 crosses are both the
Same. Well, I think as a mathematician, my instinct would be to say that actually those are the same. And the reason that I'm going to say that is because whichever way around we put the 4 and the 3, we're still adding together the same 3 numbers. So in my mind, that is the same solution for this problem. So,
okay, so that actually saves me some time.
It does,
It means
it does.
that I don't have to try all the different swappings round. I can just find a solution, and then if it's going to involve adding the same numbers again, I can just say this will be the same.
Yeah,
Okay.
absolutely.
Have we had any other interesting comments?
We have had some interesting comments. Mrs. Colwell, linked to what we just said, Mrs. Colwell has asked, should we keep track of all the solutions? So should we have a way of recording the different solutions, even when we do think they're the same? Well, I hope now, Mrs. Caldwell, that we've answered your question. You may well, your group, have sort of grouped together some crosses which you felt are the same, and hopefully now we've addressed that. I've got one more question that I think is going to be useful for all of us. This was from Crossall Junior School, and they say, how do we know we've found all the possibilities?
Oh, that's a really good question.
Isn't it a good question?
I think that might be one to come back to when we come back in a few minutes' time.
Mm-hmm.
And so if you think you've found a way to convince yourself you've found all the possibilities, then take a photo of that and upload it to us, because we would love to see it.
Okay, so we'll come back again in a few minutes, give you some more time to refine your solutions, and we look forward to hearing from you. Welcome back. We hope that little bit of extra time has given you a chance to think about Crossall Junior's question about how you're going to be absolutely certain you found all the solutions. Let's take a little look at what some of you have sent in for us.
Okay, so we've got a solution there. That's from Abby at Gospel Oak Primary School. We've had lots and lots of solutions coming in. In fact, almost too many for the team to keep up with. Somewhere on the screen, I should have Lily's group. Here, look. So Lily's group. Everybody's sending them in so quickly that I'm struggling to get it to open now. So let's just get right. Let's just switch back to the visualizer for a moment, Liz, because you can show us the solution that Lily sent in, even though we can't actually.
I can indeed.
Get it up.
Now,
so
I think one of the solutions was I think they had done something like this, and they'd got a solution.
Yes, that was right.
Is that right?
Number 5 in the middle. And then they had 2 and 3 going horizontally with the 5, and 4 and 1 going vertically with the 5. So if you like, this made, I quite like the terminology that I've seen some people using of the magic total. That's really nice. So here the magic total is 10. The horizontal row adds to 10 and the vertical column adds to 10. And I believe that Lily's group also found a magic total of 9. Now let's see, can we think about how the numbers were arranged there, roughly speaking? Let's have a think. I wonder if it was something like that. I'll give you a chance to check that. I have to check it myself. 4 and 3 and 2. Yep, that makes 9, great. 5 and 3 and 1, 9. So here we've got a magic total of 9. And I think when we set up the challenge, I don't know whether anybody took note of this at the time. I think the magic cross was like that,
this, something like this.
It might have had the numbers swapped out, but we've decided that's the same magic cross.
Precisely.
Anyway.
So here, I believe we've got 5 and 1 and 2, a magic total of 8. So we found a magic total of 8, a magic total of 9, and a magic total of 10. Just to help you see that, I wrote them out just to summarise. So this is the one that we gave you in the first place, and here are the 2 that Lily's group at Cardinal Newman School found. Now, how do we know that we've found all these possible solutions? I wonder whether anybody can help us to think about that. I think some people are saying that what they did is they found, as we've already said, we've got a magic total of 9, a magic total of 10, and a magic total of 8. So one way to think about it would be, okay, so how about, can I make a magic total of 7? Can I make a magic total of 11 and work from that way? I've also heard actually that some group I think started, and the way they thought about it was having a particular number in the middle, and you may have noticed actually that Alison and I were talking in those terms. So we've got a 1 in the middle.
We've got a 5 in the middle.
We've got a 5 in the middle and we've got a 3 in the middle. Okay.
I wonder if anyone could make a magic cross with a 2 in the middle or a 4
in the middle.
So it feels like we've got some more questions to explore now. I mean, these are the ones that we've thought you might find interesting. So what's special about the magic crosses we've found so far? How do we know we've got them all? We've already touched on that a little bit. But also, what other questions would you like to explore? What does this prompt? What, as a starting point, where do you want to go next? What do you want to explore next? So I think what we're going to do is we're going to give you a little bit more time to start thinking about these questions, and then we'll come back together in a few minutes' time in order to round this off and unfortunately to say bye-bye, because we've only got about 10 more minutes left, Liz.
Oh. Hello again.
Yeah, welcome back. We've just been having a look at everything that's been sent in. In fact, let me just show you some of the files that are coming in. We have received so many solutions coming in. We are looking at them all. We will look at all of them afterwards, even if we don't show what you've done here, but we just have a couple that we would like to share you. So I know, Liz, though, that you had another question came in on the chat.
Yes, that's absolutely right. So Abby at Portswood Primary, she asked a really good question, and she said, is a 5, 1, 2 in a vertical arrangement the same as if we had 5 and 1 and 2 in the horizontal arrangement? Excellent question, Abby. And I think my answer would be the same as whether we swap the numbers around. As we're adding the same 3 numbers in both those cases, I think we'd count those as the same magic cross.
Okay,
there's a very nice
look at whose solution was
Bethany, I think.
Okay, so this is Bethany's
that's right.
group.
Bethany's group.
And Bethany's group sent us this solution.
I love the way that they've written there about what they noticed. That's it's really useful as a mathematician to jot down when you notice something, even if you just park it for a minute.
And they've talked also about using their number bonds to 8, so that you've got the 1 plus 2 plus 5 is the same as 3 plus 4 plus 1. So I think Bethany's group are thinking about a magic cross having, you could swap the horizontal and the vertical round and it would still be the same cross, really. Let's have a look next and see this solution that came in. It was Amaya's group, wasn't it, that we wanted to have a look at? And this had some really interesting noticings on it. So they've said that they found a rule that only odd numbers can go in the middle. So they've got this one with 5 in the middle, this one with 3 in the middle, this one with 1 in the middle, and that there were only 3 possibilities and anything else would just be switched round. So I wonder if anyone's managed to explain why it has to be an odd number in the middle. That's quite interesting. And then we had one more file that we wanted to have a quick look at, which is what Xavier's been working on. And so Xavier has shown us this. The middle number must be odd in order for the cross to be a magic cross, so the same that we've just had noticed already. And he's showed you that with the 2 in the middle, you've got the magic total of 8 going horizontally and 9 going vertically, so it is not a magic cross because they would have to be the same. But if you put the 3 in the middle, you can have 9 as the total horizontally and vertically. So that's then magic cross. And he's also put this, that he's noticed the outside numbers must be separated, and the lowest and highest number, you can't quite see it all on this screen, the lowest and highest number, not including the middle number, have to be opposite one another. So I think what he means by that is that on the right, on the magic cross, the numbers 1 and 5 are the two extremes, and then 2 and 4 are sort of each one in from that. So he's noticed some structure just there.
So we are rapidly approaching the end of our webinar, unfortunately, and we'd love to leave you with a question, and several questions. One of the things you might want to think about is, why is it that we can only have a magic cross with an odd number in the middle? Can you think about the maths that you know and reason through why that's the case?
I came up with some other questions.
Did you? Brilliant.
I'd like to explore.
Yeah, do.
We started with the numbers 1 to 5. I wondered if I was allowed to break that rule and use some different numbers instead. So maybe I could use the numbers 2 to 6, or the numbers 3 to 7, or the numbers 4 to 8, maybe. Or, I mean, do they have to be one part? Could I do something like the first 5 even numbers or something like that?
Why not try it and see?
So there's lots of possibilities to explore. What can people do if they want to carry on working on this problem, Liz, as a follow-up to the webinar?
Good question. So we have created this task on the site. If you would like to look at it on the site, and the exciting thing is this is now one of our live tasks. So you can submit your work, your solutions to us. If you go to enrich.maths.org/magic crosses, all one word, then you will find the problem. You'll see that there's a link that you can submit solutions to us, and we're really looking forward to seeing those. We will put that link on the webinar page that you are now on once we have finished today.
And we're also going to make sure that it appears in the live problems as part of the feature that we're publishing at the end of next week, at the end of this week.
Yep.
So in the same way that you usually find the live problems on Enrich, it will be sitting there waiting for you. And you've got until the 4th of February
That's right.
to send in your solutions. So you can write up everything that you've done today and any further thinking that you do about the problem, and then send it in to us. And we're really looking forward not only to reading everything that you've sent us already, but also everything that you're going to send us before the 4th of February. So I think that's all we've got time for.
Unfortunately it is. So we've really enjoyed working mathematically with you all. Thank you very much for your participation.
And we really look forward to some of you joining us again for our next webinar. Bye-bye.
Bye.